We make orthopedic implants such as bone screws and bone plates and shoulder implants and hip joints and knee joints, that kind of thing. We also do a lot of medical instruments that are used during surgeries. It's challenging to be able to do the on-time delivery and give the customer the quality they want. A lot of parts have the geometric dimensioning, tolerancing, very close tolerances. So we have to take all that into account when we manufacture a part. Some parts we do are very complex. The machines are 9-axis machines that are complex machines and complex parts, so it compounds how difficult the whole process is of making something. And then trying to make that process easy for the operator to understand. As technology changes and advances, a lot of customers know what they need, and things can be made now that couldn't be made several years ago. We can make parts we couldn't have made a few years ago because of these machines, because of technology changing. We're going from a 3- and 2-axis machine, now we have a 9-axis machine that can way more complex, way more complicated, can do a lot more in less time. We have Mazak, Integrexes, Mazak, MSYs, several different models of Citizen. We have 10 Swiss machines, they're all Citizens. We have L20s, L32s, A20s, and the L20s, we have 3 different types of those. So all those, we have post-processors for to make the programs correct. And so once we do an Esprit program, we can easily post out to different machines if necessary. With the Swiss, we used to actually not even have any type of programming software for it. We had to hand type all the programs in, which we could do a lot still turning and milling. But when it came to complex parts where we had to calculate a radius or calculate things, it took a while, was very cumbersome, very error prone again. So that's something that took us a while. And we had to stop the machine while we're at the machine programming. So the machine was not running parts. So now we have something we can program offline, have the programs done. As soon as the machine comes open, plug the program in, have it simulated, we know everything's right, and it's ready to go. We want to stay competitive, and that gives us the machines we have, the skill we have, software we have, all gives us the competitive advantage of what we need. It is a more fulfilling job being able to make something that actually goes into a human body and helps longevity, helps life, helps people live better, as opposed to just making things in general for whatever. I guess perk of the job is to help people.